Is consciousness the ground of reality? There is a question that keeps physicists awake at night. It has no agreed answer, and some say it never will. The question is this: why does consciousness exist at all? You are not just a collection of atoms bumping around, you experience things. There is something it is like to be you. The redness of red, the pain of pain, the feeling of wonder as you contemplate the stars. These experiences are undeniably real, yet they do not appear anywhere in our equations. Physics describes the motion of particles, the curvature of spacetime, the flow of energy. But nowhere in these descriptions does it say how or why any of this should feel like anything. This is called the hard problem of consciousness. And increasingly, physicists are wondering if quantum mechanics might hold the key. Welcome back to the Conscious Observer. Today we ask the most profound question of all. Is consciousness fundamental to reality itself? Philosopher David Chalmers divided the problem of consciousness into two parts. The easy problems are questions about function. How does the brain process information? How do we recognize faces, form memories, generate speech? These are called easy not because they are simple, but because we know what a solution would look like. The hard problem is different. Even if we mapped every neuron, understood every chemical signal, predicted every behavior perfectly, we would still face a mystery. Why is there subjective experience at all? Why does information processing feel like something from the inside? A perfect robot could process identical information without any inner experience. Yet we are not zombies, we have an interior world, and nothing in physics explains how matter generates this interior world. Some scientists dismiss the question as confused or unanswerable, but others believe we are missing something fundamental about the nature of reality. Recall from our previous episode the measurement problem in quantum mechanics. A particle exists in a superposition of states until measured, then it collapses into a single definite outcome. But what causes this collapse? The equations do not tell us. Some interpretations, like many worlds, say collapse never happens, but others suggest something extraordinary, that consciousness is what collapses the wave function. This idea traces back to the early days of quantum theory. John von Neumann, one of the greatest mathematicians of the 20th century, showed that you can place the cut between quantum and classical anywhere in the measurement chain except at one place: the mind. The detector is quantum. The computer recording the data is quantum. The neurons in your brain are quantum. Only when the result reaches conscious awareness does the chain terminate. Could awareness itself be the missing ingredient in quantum mechanics? Eugene Wigner, a Nobel Prize-winning physicist, took this idea seriously and constructed a famous thought experiment. Imagine a friend in a sealed laboratory performs a quantum measurement. According to quantum mechanics, until you open the door and ask your friend what happened, the entire laboratory exists in superposition. Your friend is simultaneously in two states, one where she saw the particle go left, one where she saw it go right. But your friend certainly does not experience being in two states. She experiences one definite outcome. So when does the collapse happen? For your friend, it happened when she looked. For you, it has not happened yet. Whose consciousness matters? Wigner concluded that consciousness cannot exist in superposition, and therefore consciousness must cause collapse. He later distanced himself from this view, but the puzzle remains. The experiment, now actually being performed in laboratories, continues to challenge our understanding. Physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed one of the most detailed theories connecting consciousness to quantum mechanics. They call it orchestrated objective reduction, or OR. Penrose argued that the brain is not a classical computer. Certain mathematical insights, he claimed, cannot be reached by any algorithm. This suggested the brain might harness non-computable quantum processes. Hameroff identified a candidate: microtubules, tiny protein structures inside neurons. According to OR, quantum superpositions occur in microtubules and collapse in a specific way that produces moments of conscious experience. This collapse is not triggered by measurement, but by objective features of space-time geometry. Consciousness, in this view, is built into the fabric of the universe, exploited by biological evolution to create minds. The theory remains speculative, but recent experiments have found quantum effects in warm biological systems previously thought impossible. Some philosophers and scientists have taken an even more radical stance. What if consciousness does not emerge from complex computation? What if it is fundamental, like mass or charge? This view is called panpsychism. It suggests that every physical system has some form of experience, however primitive. An electron has a tiny flicker of interiority. A rock has some minimal form of experience. Human consciousness is not generated by matter, but is matter experiencing itself in a highly organized way. This may sound absurd, but it elegantly solves the hard problem. If experience is fundamental, we do not need to explain how it emerges from non-experience. We only need to explain how simple experiences combine into complex ones. Integrated information theory, developed by neuroscientist Giulio Tononi, formalizes this intuition, proposing that consciousness is identical to integrated information, something that exists everywhere in varying degrees. Here is something curious. The equations of quantum mechanics describe the evolution of wave functions beautifully, but they never describe what an observer is. The observer is outside the formalism, looking in. This is unlike any other theory in physics. In Einstein's relativity, observers are physical systems with clocks and rulers. In quantum mechanics, the observer is a ghost, essential to the theory's predictions yet never formally defined. Some physicists see this as a bug, a temporary placeholder until a better theory arrives. Others see it as a feature, a hint that consciousness cannot be derived from physics because physics already presupposes it. Perhaps we have the relationship backwards. We assume matter is fundamental and consciousness emerges from it. But what if consciousness is fundamental and matter emerges from it? What if physics describes the structure of experience rather than a world independent of experience? This brings us to philosophical idealism, the view that reality is fundamentally mental. This is not mysticism. Serious physicists have entertained it. Max Planck, the father of quantum theory, said consciousness is fundamental and matter is derived from it. Arthur Eddington, who confirmed Einstein's relativity, wrote that the universe is of the nature of a thought or sensation in a universal mind. More recently, physicists like André Linde have suggested that consciousness may be as fundamental as spacetime. The mathematics of quantum mechanics, particularly the role of information and the observer, seems more compatible with an idealist metaphysics than a materialist one. This does not mean the physical world is not real. It means the physical world might be what consciousness looks like from the outside, while experience is what it is like from the inside. We must be honest about the limits of what we know. No experiment has definitively proven that consciousness collapses wave functions. No theory has been universally accepted. The connection between quantum mechanics and consciousness remains speculative, intriguing, rather than established. Many neuroscientists believe consciousness will eventually be explained by classical computation, no quantum mechanics required. The brain is warm and wet, an environment where quantum coherence should rapidly decay. Yet we cannot ignore the persistent mystery. Quantum mechanics refuses to work without observers. Consciousness refuses to be reduced to equations. These two mysteries point at each other across the divide between physics and philosophy. Perhaps they are one mystery wearing two masks. Or perhaps we are still missing something fundamental, a revolution in understanding yet to come. Here is what we can say. The universe is stranger than we supposed. Matter is not solid. Reality is not fixed. Observation shapes what exists, and consciousness remains the deepest puzzle of all. Whether mind arises from matter, or matter arises from mind, or both arise from something deeper we do not yet understand, one thing is clear. You are not separate from the cosmos you observe. You are the cosmos observing itself. Every question you ask changes what you find. Every moment of awareness participates in the ongoing creation of reality. This is not poetry. This is the implication of our best physics. In our next episode, we will explore what this means for our understanding of time, choice, and free will. Does the future already exist? Can the past be changed? And what role does your consciousness play in the unfolding of time? Until then, remember, you are not a witness to the universe. You are the universe becoming aware of itself. Keep observing.